So far, we've written a few different functions that take as input n and as output return some list, or in this case, a NumPy array that alternates 3, 8, 3, 8, and so on, and has length n. Let me just evaluate this. And so here we're starting a new session in Jupyter, and let me try to run this. Say I do Alt3 of 10. So I get this name error, name NP is not defined. Okay, so remember you have to import NumPy each time you start Jupyter. So if you want to use it. So import NumPy as NP, and then let's redefine this. And now if I try Alt3 of 10, it should work. So I want to show you that this Alt3 function, it's much faster than the list version. So let me make a list version that's as similar as I can get to this. So let's say def Alt4n, and this is going to be similar to the very first one we made. So what is this doing? This is making a length n NumPy array of all threes. So let's do the same thing, but for a list. So let's call it my list, start with it being empty, and then for I in range n. Okay, and then what do we want to do? Well, for each of these n times, we want to put a 3 onto my list. So my list.append 3. Okay, so now we have matched this portion, this line here. Now let's try to match this portion. And I'll say for I in range. In the analog of this slice here, using range, it's very similar, just have to use commas instead of these colons. 1, and I don't think I can leave it blank as far as I know. So here I should put an n. Okay, to say go up to but not including n. And then for each of these odd indexed entries, we do my list. I almost did append, but that's not right. I need to change the element in that index to an 8. So I say my list bracket I equals 8. Okay, and now let's return my list. And if I do this, it's going to be wrong because of this indentation. I want this return to happen after this for loop is finished. Okay, so I need to unindent here. Okay, that should work. Let's try Alt4 of 10. Okay, basically the exact same. Main difference is this one's returning a NumPy array, this one's returning a list. Okay, and so far we have seen for loops and if statements. There are also while loops, and that's a fundamental construction in programming. So we haven't seen while loops yet. Let's use while loops here to find what is some length where Alt4 takes, how about 5 seconds to finish? So let me show you how we can do this. Like if I just want to know how long does it take to evaluate this. I can use time it, but a problem here is that if I want to save the amount of time with a variable name, like say I want to save it with t, then I don't personally know how to do that using this time it magic function. So we're going to use a different strategy. And maybe just as long as we're looking at this, I'll point out that before we have seen milliseconds for thousandths of a second, and we've seen nanoseconds for billionths of a second. So nanosecond is a much shorter period of time than a millisecond. And this is in between. This is microseconds. So this is millionths of a second. This is 10 to the negative 6th. So it goes millisecond, this, which is microsecond, then nanosecond, as we go from longest to shortest. And so let's find some alternate way to time this that uses some method where I can get the time as an output. Because here I don't know how to access this number other than by copy pasting it, but that's not something that's going to work if we put it into a complicated loop. So the way I know how to do this is with a module called time, and we have to import it. You don't have to install it. It's automatically installed with Python. And then we can say time.time. And I didn't look up what this means, but it is number of seconds since something in the history, I assume, of Python. So if I do it again, okay, I guess 14 seconds went by from when I evaluated the first one to when I evaluated the second one. So let's see an example. Maybe I'll make the number a little bigger, but we can say start equals time.time. Then let's run this alt4, but with a bigger input. Let's do 1,000, so 10 to the third. Let's say end equals time.time. So start is going to be what time was it in this weird seconds notation? What time was it when I began this cell in Jupyter? Then this runs, and then this is what time was it after the running finished of this line. Okay, and then I can set t equals, okay, the bigger one is going to be end, so let's do end minus start. Okay, it looks almost instantaneous. Let's check what t was. Okay, so it was like 0.0003. Okay, great. And so I mentioned that I want to use a while loop. So I want to find what is a size of an input where we get, how about 5 seconds for alt4? So let's just start out with t equals 0. And then let's say while t is less than 5. Okay, and then I'm going to keep doing something. So let's say our starting input is 100. So let's say n equals 100. And initially, I multiplied this by 10 each loop or each cycle through the while loop. But this alt4, it slows down like so much as the inputs get bigger that I want to make a less drastic change. I'm going to multiply by 2 instead of multiplying by 10 each step through the while loop. So I'm going to say n equals n times 2. Okay, if you wanted, you could also do n times equals 2. Okay, those are the same thing. And then I'm going to follow this same procedure here. And let's make sure I get the indentations right, so they're all happening inside the while loop. And so what is the only thing I want to change here? Only thing I want to change is this should become n. And I don't have to save it or print it or anything. All I care about is how long does that take to run. And just as a reality check, we get something like n equals 1 billion or whatever. Then we run, assume 1 billion takes 5.7 seconds. Then this will take 5.7 seconds. So this t will be 5.7. So this condition will be false. So we will leave the while loop. And then I can check what is n. Okay, and it'll be that billion. So if I had instead put this n equals n times 2 at the end of the while loop, then it would not be correct. I'd have the wrong value of n at the end. So it's good that I change n, then do the measurement, then potentially leave the while loop. Okay, so let's check. And this might take about 20 to 30 seconds, but when I was multiplying by 10 each time, then it was taking much longer, taking maybe 2 minutes or so. Okay, great. And now notice this isn't in a function or anything like that. So the values like t and n that I defined in here, I still have access to them. So let's see t first. Okay, 5.25 seconds, perfect. So when we check n, this is going to be a length where alt4 takes 5.25 seconds to run. Okay, and so what is this? This is the 800,428,052 million. So took about this long, or it took about 5.2 seconds for alt4 to work with 52 million length list. So let's see how long it takes for our alt3. Maybe I'll put it back down here just so we can look at it. And so let's time it the same way. So let's do this, and let's get rid of these indentations. The way I'm going to get rid of these indentations is I've highlighted all of them, holding down Shift and then hitting Tab. And N will be the same. It'll be the same 52 million number. Okay, let's just print N to make sure about that. And let's then print T. And you see what mistake I'm making here? I need to change this to Alt3. Okay, so N is the same, and instead of taking 5 seconds, it took less than half a second, so over 10 times faster with Alt3. You might complain that this Alt3, it returns a NumPy array instead of a list, and surprisingly, that slows it down quite a bit. So let's change this to Alt3b. And let's return the list version of A. Okay, so if I try Alt3b of 10, now you can see it's a list instead of a NumPy array. And let's try this and see how long it takes. So you can tell it's taking much longer. So it's almost the same length of time as Alt4, the one that didn't use NumPy anywhere. So in general, unless you really need it to be a list, you'll save a lot of time by not doing this conversion at the end. Maybe one more thing I'll try is let's look at this Alt4. And let's just do the same thing, but with NumPy instead of lists. So let's call this Alt3c. And let's go ahead and make, so I'm sort of going halfway here. Let's go ahead and make the array the same way to start. So what this is doing is it's making a length n NumPy array of all 3s. And then the part I want to match from Alt4 is I want to use this for loop to go through and change the ith entry in A. I want to change that to 8. Okay, and then I want to return A. And let's see how long this one takes. So I'll change this to 3c. So you can tell that this one also it's a little faster than Alt3b, but it's still much slower, still over 10 times slower than the one where we used this A1::2, this slicing syntax and assignment of 8. So one of the lessons from this is that you can really speed things up by avoiding for loops. So this method here, where we just said, change all of these odd indexed entries to 8, that was much faster than this one where we iterated over all of the odd index or all the odd indices and then changed the corresponding value in A to 8. So lesson of that is when you have a way, lots of times it'll be in NumPy, when you have a way to avoid a for loop, it's often a good idea to avoid the for loop to make things more efficient.